Hi there, welcome back to the channel. And welcome to something completely different. This time it's the first portable tube radio that I work on. It's a Philips Model 148. It's also known as a Town & Country 148 and also as a Mullard MABS 1052, I think it is. This was made in Australia, so I'm actually treading on Dave and Don's territory. But I really wanted to work on this. This is really a very, very simple set. It's it's medium wave only. I really like the design they've got on there. It is a Philips, so anything can happen. We've got to be ready for some surprises. But I'm looking forward to putting one of these in my collection because I really have been curious about this the portable thing. You know, the battery and main sets, meaning that with a battery, there's got to be some lower voltage for B+. I can't imagine it going up to 200. They usually go about 90 volts. So this thing obviously has the two options. I'm curious to see what the intricacies are, what the differences are. I'm sure they'll be very different to the radios that I normally work on, but we've got to branch out and try something new, otherwise it just gets boring. So if you enjoy this sort of thing, and especially if you're Australian, stick around and enjoy the video. Before we carry on, I want to thank the sponsors of the video, PCBWay. You'll find them at PCBWay.com. These are the guys I go to for all my PCBs. And lately I've been looking at some of the other services they have, which are quite amazing. If you look at their products and capabilities page, you will be surprised, and I'm sure you'll find something for your needs. The one thing that's piqued my interest though, when you go to the details page for placing your order, you'll see all the options they have here, from the size to the number of layers to the type of material, thickness, and so on and so forth. Admittedly, I've used mostly the standards, but the one thing that I really like is some of the colors they have. This matte black I've used before. It really looks good, and especially if you use a particular surface finish like immersion gold and selective gold. I'm dying to try one of these because they really look cool. I've seen some other guys use them and they really do look great. So if you need any PCB work done, go to PCBWay.com. I'm sure you'll be satisfied. This is the first portable tube radio that I've ever worked on, and it was made in Australia. Yep. Made in Australia. This is the Philips Radio Player Model 148, and I've also found that it's called the Town & Country 148, made by Philips Australia, and also the Mullard MABS 1052, made by Mullard Australia. So, first radio I've ever worked on from Australia. And so if I need any help, Don's Radio Shed, Dave Tipton, I might have to call you. I ordered this one because I was curious about the portable tube radios. I think this has got a vibrator inside that basically steps up the voltage from the battery to the B+ that you need, probably 60-70 volts, I'm not sure. I had very little information on this, but I have found a schematic, and then I found a sort of service manual, which makes things a lot easier. Now the condition is pretty good. It's got Bakelite sides, well, at least I think it's Bakelite, and they're in perfect condition. The front is metal, and it's sort of discolored. I'm hoping that I can clean this up nicely. I think I will be able to. And then there are these two knobs, which are just about the only controls you have on here. Now this thing is only medium wave, and something I've also never come across before is that there are no frequencies marked on here, at least that I can see. All you've got is regions of Australia and the different station markings or station codes. And I'm sure if you're Australian, you'll know what they're talking about. NSW, New South Wales, I presume. Vic, Victoria. QLD, Queensland. What is that? SA, South Australia? Not sure. DSW, I'm not sure. Victoria, WA, Western Australia, Tasmania. And then you've just got text on here with these station codes. I'm sure that in the alignment, they'll tell you to put it to a particular place and explain how to do it from there. But there is nothing else on here. There's the tuning, which is working, thankfully, so the dial cord is fine. And then there's this, and I think that is just a volume control. And I would expect this thing to switch off down here. I would expect this to have a switch down here, but it either doesn't work or there isn't a switch down here, which I found kind of strange. The speaker grill over here, I can't see through it. There seems to be cloth at the back, but it seems to be fine as well. And if we turn this around, the back is almost as bare as the front, if not more so. There's a hole there and a portal. I think that would be for mains. Oh, and it closes by itself. Good show. and two little things on here. I wonder if this is for an antenna. I'm not sure. I'm going to open this up. I haven't looked inside yet. I don't know what to expect, but it is in such good condition. The back is probably as good as the front. The handle is perfect. Needs a bit of cleaning, but it's perfect. And although this is only medium wave, which will be of very little use to me, I'm actually just as excited to get this working as if this was a Saba or a Grundig with FM and all the bells and whistles. I expect it to be simple. I expect it to be very compact. Let's open it up and have a look. I don't even know how to open this thing. Well, it looks like it's as simple as removing two screws, or I'm not even sure if you remove them. I think you just loosen them. Yeah. And this thing should come up. Ah. Okay. That was easy. The lid can't go any further. It's held in place with this. That's where the battery compartment would be. Quite a big space for a battery. I'm not even sure what kind of battery it uses. This is the battery connection. There we've got what I can only presume is the mains connection. I'm not switching this on till I find out. And yeah, it is a little bit compact in there. I'm not sure how I take this out. I think there's some desoldering that needs doing. But I'm going to have a look at it. I'll get back to you and tell you what I've done. All I did here is I removed this from that cover. And just to make sure I don't lose it, I'm going to put those back. And we've got a good view of the inside. 1, 2, 3, 4, 5, 6 tubes it looks like. Not sure if that's all it is. And now we've got some, I wonder where you take it off. I think you remove that one and that one because I see a little bit of bakelite coming out the side here. I'm wondering if that's all that's holding this in. There are wires going to the side. It looks like the antenna is on that side plate. And another antenna on here. That's a little bit odd, but I'm going to remove these guys and see if the whole thing comes out. Did anything come loose? Yes, it did. Right, I'm going to do this off camera because I don't want to damage anything, but I'll tell you exactly what I did when I do it. I removed these two screws and they came out quite easily. Then I had to remove two screws at the top, and those were under the handle, so I had to remove one screw at the end of the handle to lift the handle up, get access to them. And now it seems that things are loose, but there's a wire down here. And what I'm going to do, just to ensure that I don't forget about it, there's enough length, so I'm going to leave a little bit on there and cut it. I'm still not sure that that's all there is, but we'll find out. I'm wondering if there's more wire on this side. Usually this just slides out. Let me try that without the camera again. I better record this before I forget what I've done. What I had to do, there's another wire down here, the black one that's connected to that side. I cut that as well. I've got this cloth covered wire, so I can remake that. I think what I'll need to do is remove the side actually when I put it on. But that came out because then this thing lifted out and that sort of angled the radio out of the set. Now something has fallen off here. Oh, that's underneath those screws. So it's on the top here where the screws go on. Okay, I'll keep a record of that. And what we've got now is we've got the chassis. Pretty compact here, and I think it sits up okay. Yes, it does. We'll have a closer look at that in a minute. Let's have a look at the case. The case inside is actually in very good condition as well, and there's a loop antenna on there which is then wired across to this side. That's why we've only got wires on the one side. And here we've got that loop antenna, and the wires come onto here. There's an antenna trim over here, and the two wires, the one that I've cut there, the one there, that's obviously a ground. And then this thing actually flips up. I heard it snap into place. So this is a cover for that dial, and that's working quite well. It actually flipped down when I was taking it out. I got a hell of a fright, but nothing was broken. There is a cloth on here underneath that cardboard. That's just a board. and that can come out clean as well. There are two little clips on here that hold that in place. All this has got is a bit of dirt. The case is in perfect condition. That's beautiful. Beautiful. All right, let's have a look at the chassis itself. This is actually looking good. There's a lot of dirt on here, but it's turning fine. Phillips with the dial strings turning fine. That's rather unusual. I'll have to remove that to clean that. It's sort of tarnished. I'm not sure that I think I might have to paint that, but that does come off. This is obviously all rather different than the usual, but here's our pot volume control. I'm still wondering about the on-off switch. I find it strange that there's no on-off switch, but it doesn't have a switch. No, it doesn't. There's no switch on here. However, this could be the switch. Yeah, okay. That cover that comes down, this could be the way they switch it on. There's a switch here. I'm not sure what it does. This is a bit loose, but actually that sliding cover could be the on-off switch. That's very clever. Very clever indeed. Okay. All that just needs cleaning, and then we've got some components, but let's have a look at the, as I said, there's that switch. Some tubes on here. These tubes I'm not accustomed to. I'm just praying they're working. Tuning condenser in there, and it's all moving freely. The usual Phillips trimmers over there, trimmer caps. There's the output transformer down there. I'm obviously going to have to take off the speaker to get access to those components, because that looks like a filter cap over here. I know I'm being rather dumb, but I can't see how the voltage gets stepped up. This over here is the power supply. We've got a mains transformer, it seems. One of those death caps. A lot of caps here, a few caps here that need replacing. This here would be to switch between battery and power, because there is a switch function. It's not just to cover the power prongs. There is a switch function in there. And a wafer over here. It's very dirty. But other than that, there's not much in terms of components on here. And I'm wondering how you get to the components, because you can't really get to them there. Let's have a look on the underside. Oh, okay. This underside comes off. I'm sure it does. Yeah, there's two screws, two nuts over there. Take them out and see what we're facing. Doesn't seem to be that much to it. There's an electrolytic down there, another one there, another one there. This seems to be a big resistor, probably to, well, let me not guess. This is all mystery to me because I've never worked on one of these, but I see a lot of capacitors here that need changing. A few micas that should be okay. There isn't that much to it. This is really completely different to the German sets that I'm used to, which are incredibly over-engineered. Australian made. Okay. Dave and Don, this is your bailiwick. All Australian components. Well, how fancy is that? Okay, I guess I better get a big knife to work on this. Anyway, it looks pretty simple, I think. This is a Phillips, so I have to be careful what I say around it, because it is still a Phillips, even though it's made in Australia. And it could still come and do the usual thing that Phillips tends to do, which is bite me in the ass. A few resistors. Some of these are really old. This, I believe, is 1957, if I'm not mistaken. Or is it 52? Not sure. As I said, not much down here. Not much at all. These two guys over here are IF transformers. I'm not sure what kind of battery this thing used. Oh, I know what this did. Okay, I think I know what this did. That's why this space for the battery is so big. I think this thing took probably a high voltage battery, maybe a 48 volt battery or something like that, or you can get there with multiple PP9s or PP3s, I think they call them. I know when I lived in South Africa, we used to have a PM3, PM9, PM, what is it? There was a big one. They were all 9 volts, but I think there were other batteries that went to higher voltage. I've seen people build these up with those 9 volt, small 9 volt batteries. you can just put them in series and get up to, well, if you put 10 of them, you get 90 volts. But it's an expensive way of doing it because those batteries are not cheap and they don't have that much power. They probably will drain quite well. Now this would also need a low voltage battery for the filaments, which I think would be, these tubes are marked as 1 something. I think they might even use 1 volt as the filament voltage. But again, time for me to study the schematic before I get cracking on this, before I make a mess of anything. I find the mechanics of this quite interesting. I actually do like it. And it's got a fantastic speaker. I mean, this speaker looks really good. The tuning is working. The volume is working. It's not even tight. And the rest is what we do. We just take it one step at a time. You know, you learn now and 5 minutes later you're an expert. That's what we do. These tubes are scaring me because I've never seen them before. They are Phillips, but they are the small ones, and I presume they were made, oh dear, oh, there's some grommets that have gone. This would probably be, what is that, IT4? That squeaked to me. If it was an ECH81, which I think is what this thing would be doing, then I'd understand it a lot better. But I think it's probably, again, these things aren't that complex. Probably power tube, detector, and preamp, IF, maybe another IF, I don't know. What is that guy doing there? That might even be a rectifier. I'm not sure. I'm just guessing now, and that's dangerous with these things. Time to study and get cracking. All right. I'm pleasantly surprised. This is in very, very good condition. I was worried. I'm still worried. You can see leads connected to this, so you can guess where I'm going with this. What I wanted to do was to test it under very controlled conditions. I know this thing uses 9-volt battery for the filaments. If you add the filament voltages up, it shows you on the service manual, it adds up to 9 volts. And I've got that connected over there from the one power supply. And then it uses 90 volts on the B+. So a 90 volt total battery voltage to the B+. And the first point you get to on the B+ is that filter capacitor over there. So what I wanted to do was to actually test this with battery, or rather with a current limited power supply, to see if I've got anything. Now, I can't go as high as 90 volts. I can go as high as 60 volts. And my logic is it should do something, right? I mean, the heater should light up. It should do something. Now, what I've done is I've tested the heater connections. There's continuity. They've all got about the same or acceptable resistance in the heater lines. So the tubes seem to be fine as far as the heaters are concerned. No heaters opened. This is a series chain. So you've got to have all the tubes in and make sure that there are no open heaters. Otherwise, none of the others get heater supply. And the results weren't very promising. Let me show you the supplies. If I put the heaters on, it's drawing 80 milliamps. Now that's about right because I've just checked one of the heaters. Remember, the heater voltage is in series, or rather the heaters are in series. So the current going through all the tubes will be exactly the same, all the heaters. And it gives me, for the 3V4, 50 milliamps of current, which is, well, fairly close. I mean, the precision of this particular meter is not that good. So it's giving me about 50, 80 milliamps. So it seems to be lighting up the heaters, and I can see some of them lit up. Now, if I switch this on, it's got 60 volts. Actually, no, I've got to put serial on there and switch them on. Okay, that's better. So I've got this in series mode, so 30 plus 30, 60 volts, and it's drawing 10 milliamps, which is probably fine as well, because this is not supposed to draw much. It's supposed to draw about 14 milliamps at 90 volts, and it's drawing 10 milliamps at 60 volts. The problem is I can't hear a peep out of this. This thing is completely silent, and I've tried to, not even a scratch. Nothing at all. It's still drawing those 10 milliamps and those 80 milliamp for the heaters. So that seems to be fine, but this thing is completely silent. Now, It could be so many things at this stage. And the reason I wanted to do it like this is because all the switching needs to be cleaned. I wasn't going to trust this connector here to supply the battery because it goes through a lot of switches. I don't trust those, so I put them straight in, and I expected something, but obviously I'm getting nothing. And I don't have a short because it's drawing those 10 milliamps and it's drawing 80 milliamps for the heaters, so it doesn't seem to have any shorts. But perhaps that 60 volts is just not enough, and I can't really do much about that because I don't have a supply that'll go up to 90 volts. This is when you start needing more equipment. I keep saying that I don't want more equipment than I can use, and here I could probably use some. But anyway, that's what I wanted to do before I start the actual restoration. First things I'm going to do is go through the power supply, check switches, clean that all up. This thing needs some serious cleaning because as far as the components are concerned, it's pretty simple. Okay, curiosity satisfied. Nothing. I started at my usual starting point, which is the power supply. And what I decided to do is, as usual, just follow the schematic, you know, from the mains in, and then it goes to a sort of switch, and then it goes to the transformer and everything else. And that's where I encountered my first problem. See, the mains in is over here, these two prongs, and then goes to a switch, but it doesn't really go to this switch. This switch is after the transformer, as we'll see on the schematic. The mains actually get switched with 2 points on this wafer switch, which is that the lid actuated switch, and that's where my first problem came in. These wafers were loosened and one of them was actually cracked, so this switch was not working properly. So I decided to do the following. I had to remove this, and it's difficult to work on it. You have to firstly remove it from here, and then once you have it out, you've got to actually loosen this connection to this plate where the pot is, because this has actually got a rivet. You can't just take that out. That's riveted through. But there is a way of loosening it so that you can get to the various parts of the switch. And this thing had a wafer here. I don't know if you can see it. That wafer was cracked or broken from the actuator. So whenever this thing clicked to the other side, it wasn't putting it back. So the switch wasn't working. I've actually glued it, and I think it's working. But to do this, I had to dismantle the whole thing. And I'm just praying that I can get it back. And I decided to put this on hold while this thing dried. And I went and looked at the schematic and to see what I can do from there. And here we've got the power supply section. And it becomes pretty clear what it is we're looking at. We've got the supply coming in, the prongs coming in. This switch, that switch and that switch are all S1 and S2 operated by the dial shutter. Okay, so the dial shutter, when you open that dial and you can see the dial, the face, that's when you switch on your power. And then internally it's wired to 240 volts. I hope that's correct. There's no way that I can see it. There's no switch. It's actually soldered in place. So I'm going to trust that that's correct. We'll see that when we power it up. But I decided to skip this section while this switch was being fixed. And of course, the switch acts later as well, as I'll show you. But at this point, nothing has stopped mains from going in except this switch over here, actually, because this switch is actually the one on the back of the radio on here, okay? And it is actuated by this lever, which you pull sideways to put the mains prong on. So when you've got it like that, it's on mains position. When you've got it like that, it's on battery position. And that means that it either lets the mains through or it lets the battery through. But it does not actually switch off this supply. What it does is it stops you from plugging the prongs in, okay? So it effectively acts as a stop for you to not power the radio on if you're using batteries. Okay, I then decided to look at this section and test these various connections and these various components, and what I found is that the resistors are perfectly fine and these two capacitors were dead, so I replaced them. And I got this testing as far as this point. And this point here and here, that is your supply for your B+. As you can see, it's going up to this B+ line. And that there connects your heater supply. Now, if you're using a battery, you've got a 9-volt heater supply here, 9-volt battery, which goes up to here and feeds to the heaters of these tubes. If you're using the mains, it takes your B+ from here, it drops it through 2 pretty big resistors, and it then feeds that voltage, which is reduced by the resistors, to the heater section, to here. So that dial shutter switch has to operate for this section as well. So it cuts out both at the beginning, the mains, and also the battery connection. And that's where I've got to, and I'm waiting for that section to dry so that I can put this back and make sure that this shutter switch works well. I'm not going to be using this. I'll be testing it with a supply. Just one note, this tube is heated, directly heated through that part of that transformer. And you can see the cathode is actually one of the heater sections, so this is floating, and it comes out here as your B+, and it's rectified by that tube, which is a 6V6. That section of tubes there, the heaters are in series. Now you see you've got ground there, goes through one, through the other one, through the other one, there's a capacitor there to smooth it, through the other one, and then through this, which is actually got two sections, so it goes through the two of them in series in this case, and that's the heater coming in here. Now, the voltages you expect, or the voltage you expect, the voltage drop you expect here, are the heater voltages combined, the sum of the heater voltages. And we get that information from the service manual. It actually gives us that information here. You see you've got your V1, V2, the various tubes. This is their types. And as I said, these are 1 something, which I haven't worked with before. This is a 3V4. It says here EZ82, but it's actually wired for a 6V6. And that's got 6.3 volts heaters, which is being supplied by the transformer. That's fine. And then it tells us here that the filament voltage on battery is 1.5 and on mains slightly lower. And that sums to, if you look at this, 1.5, 3, 4.5, 6, 9 volts. These will be slightly less. We'll see what comes out of there when we switch it on. I'm not sure what voltage we're going to get. But the point is, we've got the heater supply designation here. We know exactly how it's supposed to work. This actually gives us quite a bit of information, which is great. So I think I'm ready to put this all together and test it, paint my drawing a bit more, and carry on with the power supply. This is that filter capacitor that I replaced, 47 microfarads. They said 200 volts. I've put a 450 volt one in there, and I've replaced that one down there, which was just basically a safety cap. I've put in a 1 nanofarad safety cap, same value. Other than that, I've just cleaned some contacts on this switch. I've cleaned those wafers. I'm going to clean them some more. I've done very little else because I really just want to get the power supply section tested, and I want to get to the point where I can actually hear something from this radio. Okay, I got the switch all put back together and found that it's still missing, but at least it's firm now. One of these screws had been left out, so this thing was flapping in the wind, but I'm still going to have problems with this thing. It's in the on position at the moment, and I'm desperate to try and test it again to check whether the power supply is working and whether I'm getting the voltages that I expect. And what I've done is I've connected the meter, the two multimeters, the faithful duo, little brother, big brother, and they are connected to the out position of the switch here that cuts off or powers on the secondary side of the supply. I know it's making contact. I've checked continuity to everything else, and now I want to try it. Now I need to try this with the tubes in place, because this is a series string of tubes, meaning that if I miss one, if one is open, none of them work. So what I'm going to do is I'm going to try it with the Variac, and we'll see what happens to the voltages over there on the meters, and hopefully we'll hear something. I want to hear something. I've got the mains connected here. It's insulated from there. I had to be careful, but this means now that the switch is on. So all that's left to do, I'm procrastinating, I know, but I'm a bit afraid. I'm going to show you the meters and we'll bring it up slowly. I'll leave this at an angle. If we get fireworks, I want to catch it on camera. I'll bring this supply down to about 100 volts. I've got the dim bulb tester with one lamp on. Let's see what happens. Don't expect much because the actual rectifier tube needs heater voltage as well. So remember, this is measuring the heater chain voltage. We're supposed to get, what, 8 volts I think it is. 9 volts if it was battery, just a little bit under if it's the main supply. So far I've got nothing. Volume up. Volumes on max. Not that I expect much. It's starting. Well, we don't have any bangs yet, so I'm going to give it more voltage. About 150. I expect about 90 there and about, let's call it 9 here. Yeah, it's going up nicely. I'm going to take it up to 200. Remember, my normal supply here is about 230, 240. So on 200, it's drawing 50 milliamps total from the mains. That's on 90 already. That's at 5.2. The heaters are working, because if they weren't, I'd be getting the full supply here. Remember, if you've got a heater chain at the end of some resistors, if they were open, there'd be no current draw through those resistors, so I'd get the full 91 volts. But the heaters are okay. These heaters are so low voltage and so low current, I don't even expect them to warm the tubes, but I don't hear anything. Strange. I should hear something by now. Take it up to 230. 230 volts. I've got restrictions, so I'm going to reduce the restrictions so that we get the full 230 on there. 7 volts sounds about right. Probably should be a little bit more. 98 sounds a bit high. And I don't hear anything at all. Get this to my ear. It's just a very, very slight hum when I put that right by my ear. That's not good. That's not good at all. That's a bit high, which could be an indication. That could be an indication that the output tube's not drawing current. If any of the tubes don't actually draw current, the voltage is higher because it's going through various. It'll draw current, drop the voltage. That I'm not worried about. That seems to be okay. A little bit low perhaps, but it seems to be okay. I think this thing is actually wired to 240, so I'll put this to 240. Whoops. Got that at 240 now. 7.500 volts. Something's wrong with the, I think, with the output tube. Absolutely no sound at all. Let's try something else. If I touch the center of the volume pot, zero, zilch, nothing. Bloody hell. This is what I feared. I've got a tube problem. When I touch the center of the volume pot, regardless of what's coming through there, this thing should hum like crazy. It should buzz. And it's doing absolutely bugger all. Let me think for a while. Okay, I'm being a little unfair on this because I haven't really tested much other than working on the power supply. So perhaps I shouldn't expect miracles, but the fact that we're getting absolutely nothing there worries me somewhat, and it tells me that perhaps the tube is not working. So what I'm going to do is I'm going to do two things. I'm going to stop this for now, and I'm going to work a bit further on the audio stage there. I know the supply is working. I'll check the audio section. I'll check the output transformer as well separately with my little trick, which I haven't actually done. But at least I know the supply is working. I know the switching is working. There's a lot of switching, and a lot of these switches were really, really corroded. So anything could have happened, but everything is going through as it should. And at the same time, I'm going to start looking for replacement tubes for this. I don't know where you find them. I'm sure they're available in Europe. This was a Philips tube, but I have never seen these tubes before. I certainly don't have any spares. And if one of them's blown, I think I'll just buy a whole set. And, you know, I don't want to send for one and then find that another one's gone. So if any of you know where I can get these tubes, let me know as well in the comments below. But for now, I'm going to leave it there and, yeah, and keep scratching my head and looking at the schematic and figuring out what to do next. I should have expected this. This is a Philips after all. They never work out first time. Okay, well, I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now and stay safe.